Energy infrastructure has always been built to endure. Today, it also must be built to evolve. The energy transition is here, and it's reshaping everything. As the world moves toward decarbonization, the way that we design, build, and manage infrastructure will define the energy landscape of tomorrow. Around the world, energy leaders are rethinking what's possible, designing infrastructure that's cleaner and smarter. From deep subsurface modeling to offshore wind farms, we're facing complexity head-on, turning bold ideas into real-world solutions. Digital tools are changing what's possible. In this moment of transformation, every decision we make today will impact our future. Decisions like how to use AI not just to automate tasks, but also to empower teams to work smarter and faster. How to make data flow more freely, so everyone, across every phase of a project, is working from the same playbook. And how to bring insights from the natural world into the way we design the built one. Every one of those choices, big or small, shapes the future of energy. This session is about those exploring those choices and learning from the people making them. We'll take a critical look at the decisions and digital innovations that could shape the infrastructure of a low-carbon future that's better for everyone. Because the future of energy isn't just about what we build, it's about how and why we build it. Welcome to the Energy Production Industry Breakout Session. Let's explore what's next, together.
Thank you. Thank you. Hello and welcome to the Energy Production Industry Breakout. Thank you for joining us here in Amsterdam this year, and a warm welcome to those watching online around the world. My name is Sharon Soler, and I'm Solution Manager for Energy at Bentley. I can think in a better way, to start this conversation or open up this conversation without highlighting the undergoing and profound transformation that it is happening with the energy sector nowadays. From the challenges and pressure of decarbonization and the regulatory shift to the inclusion of digital technologies and the need for better infrastructure, more resilient infrastructure, the challenges are demanding, but the opportunities are equally compelling. You have just seen in the video, very briefly, how energy production expands everything from subsurface exploration to asset operation across both traditional and emerging energy sources. So from both, we have seen an expansion and ongoing demand all over the world. Today, we will explore how industry leaders are shaping the future for energy production, how they are driving innovation all over those challenges as well. And we will hear and we will learn from them about how energy production is look like nowadays. So let me introduce them. Basim Khan is Senior Vice President Operations for McDermott and a member of its executive committee. Basim leads McDermott Project Management Office, overseeing global operations, and it is also responsible for the company's enterprise risk management program. So please, welcome, Basim. Let me introduce Alberto. So Alberto, it is digital twin director for EMEA and APAC at Horley Consulting. Alberto oversees strategy, client engagement, project delivery, partnerships, and P&L growth for Horley's digital twins, offering across both regions. Welcome, Alberto, please. So please, let me introduce Steven now. Steven is Exploration Geoscience Manager at Fervo Energy, with 17 years of experience in geothermal exploration and development, Steven has led modeling efforts for Fervo future project portfolio across a wide range of geologic settings since joining the company in 2021. So please welcome Steven. And finally, Graham Openshaw, Digital Director for a system in the UK, has worked on landmark programs drawing upon his experience in project management, engineering, and digital transformation across the nuclear, defense, and energy sectors. So please, welcome our distinguished panelists. So thank you. Thank you once again. So to keep the things dynamics, I'm proposing we run this in 3 rounds of plays, I would say. So let me explain this, how it is going to run. The first round, we will start with individual questions drawing from your experience and expertise. Then we will move to the second round, and we will open it up, the things here, for broader question for the full panels. So this is where we will connect the dots. We will share experience, and we will start to exchange more comments between the panelists. And finally, for the last round, we will do a quick Farsight. So Farsight style ending questions, just to finish, before we open the floor for Q&A, for your comments, of course. So, ready to play?
Yep.
Are you ready to play? So let's get started. Basim, let's begin with you. McDermott is known for tackling some of the most complex energy infrastructure projects around the world. So we are talking about offshore oil and gas platform to hydrogen hubs, and has a really long relationship with Bentley as well. So we have been seeing those developments really close to McDermott. So my question to you, just starting this, it is, how are the digital innovation, digital collaboration, and the integrated data environment helping actually the teams streamline delivery across those projects? So what is working right now efficiently and really in the operational side of the things, and where are we still learning?
Okay, so thank you, Sharon, for the question, and thank you for inviting me as well, and good afternoon, everybody. So, yes, we do very complex projects, and I've been in the industry 35 years now. So how have projects changed? Even recently, even when we had so-called digital tools, as we call them, projects were executed in a very discrete manner. You had an engineering block, you had a supply chain, fabrication and construction, commissioning and handover. And typically, the handover point between these phases was very manual. Now, when I say manual, I count Excel spreadsheets, PDFs, Word documents. I'll count them as manual. We call them digital, but the reality is they're not, right? They're just, you're taking what you would 40, 50 years ago type, you're scanning it, and you're calling it a PDF. What has changed now, and what is allowing us to do these very complex projects, is the ability of changing what was a discrete execution model, engineering handing over to procurement, handing over to construction, to a continuum. And this continuum is, and this morning we heard some of the speakers in the morning talk about digital threads. This continuum is actually a digital thread. So the objective here is you enter data once, and that data lives through the life of the project. Now, I'll answer the second part. What's not working is that we still have not figured out how to use that in the asset management, asset operations phase, but we'll come to that. So what has really changed is the technology today allows us a continuum in engineering rather than discrete. And it allows us to use this digital thread to collaborate. So let me explain this by a real example. We're executing a project in Canada, in British Columbia. It's an LNG project. It's not one of the biggest, but it's in a very remote location. When I say remote, it's actually only an hour's drive from Vancouver, but the only way to get there is by boat. There's no road to the project site. So the project is being engineered and project managed out of Houston. The engineering is in Mexico City and in New Delhi. The supply chain is global. We're buying compressors from Germany. We're buying big substation equipment from China, from India. It's a global procurement. The fabrication is in our fabrication yard in Qingdao. The project site is in Squamish in British Columbia. How do we manage all of these? How do we ensure that everyone is looking at the same data? It is by setting up at the beginning of a project, in this case at feed stage, a digital thread which allows everyone to share, to collaborate in the same environment. Without that, the 6,000 to 7,000 people we have on this project, everywhere from British Columbia to Qingdao in China, they would not be able to get information in real time. And it's not just a forward path. A lot of what we do is a forward path, but it's getting information from fabrication. That are we welding this node, are we designing this structural node the right way, and then moving it back into engineering. Second part of your question is what's not working. So the infrastructure we've set up for where we have command and control. We also, so in a typical project, an LNG project, but most infrastructure projects, 40% of the spend is in supply chain. Of that, half of it is in equipment and machinery. What's not working is that the data interface, what we send the supplier, and then what we get back from the supplier, that doesn't work. Because we don't really have, despite what we say, we don't have interoperability, we don't have an open network, some of the suppliers are not sophisticated, so that exchange is still manual, i.e. it's an AutoCAD drawing, it's a PDF, it's a Word file, it's an Excel. That, Sharon, still needs work. But in terms of our ability to execute, you know, these are not $100 million projects, these are billion, 5, 10, you know, the project we're doing with a JV partner in Mozambique is $15 billion. It involves tens of thousands of people. The ability to execute complex projects efficiently and without being part of that 98%, which is always late, which we saw in the morning, or always over budget, sorry. That's where the digital tools are really making a difference. When I started in the industry, a big project was $300, $400 million. A $400 million project doesn't get 3 lines in upstream now. It's not relevant. The projects today are multi-billion-dollar projects. They collaborate across not only from engineering to fabrication, but multiple joint venture partners as well. We heard that this morning as well. So without the technology today, Sharon, we couldn't do these complex projects.
Thank you. That's quite a complete answer, just to kicking off the conversation here. I do appreciate it because it's just representing the importance of the integrated data environments and interoperability, how we are still dealing, you know, with the basis stuff in terms of data management. Let's put it in that way. So I'm gonna switch a little bit and turning to you, Stephen. And I would say just starting because we are gonna move from offshore operations and risk management, we are going to move to emerging energy sources. So I'm going to start to talk here about geothermal as well. And I would say at that point at Bentley, of course, as you know, we are helping our users design, build, and operate as well assets that are not only more resilient, but are also more sustainable. This is one of our goals. So, of course, we have seen, Stephen, geothermal has been gaining momentum with hyperscalers investing to power data centers using this constant renewable energy. So in your role leading exploration at Fervo, how are you seeing tools, digital tools as Leapfrog from the Sequent portfolio, helping manage the prioritization of the projects and the increase of the project portfolio to attend the demand in the, I would say, in the broader energy mix?
Yeah, thanks for that question. So at Fervo Energy, what we're doing is really taking a lot of innovations that have been developed in the oil and gas industry, such as horizontal drilling and hydraulic stimulation and applying them in a new way to geothermal to really open up the number of places where geothermal is viable. And when I first entered the industry almost 2 decades ago, a lot of people in the industry were still using maps and cross-sections to model the subsurface. Now, this can work for smaller projects and simpler geologies, but at Fervo, we're building large-scale projects where we're drilling dozens of horizontal wells spread out across an area. And what Leapfrog is allowing us to do is take it to 3D and even 4D and extrapolate cross-sections and maps into full 3D models, which allows us to reduce risk across all the wells that we're drilling. And on every single horizontal well, we get a very precise geologic prognosis based on these 3D models that we're building in Leapfrog that incorporate extremely accurate temperature models and geologic models. And this reduced costs on our project, which ultimately makes this clean energy more available to everyone.
Yeah, wow. That's other work, you know, really interesting subsurface technology in development. Thank you for that, Steven. So let me here maybe open up a little bit the things in the digital side, Alberto. So Worley Consulting works with many major energy asset owners, embedding digital twin into large-scale energy transition projects. So my question to you, it is, since your role, it is covering 2 of the main regions around the world that are really mature and active as well, EMEA and APAC, in terms to really consume digital twin. I use these technologies, you know, to operate as well the projects. How are you seeing actually this managing complexity and simplifying actually the complexity itself in the projects and improve decision-making across carbon capture initiative, hydrogen, offshore wind? And a little bit more of that. What are the customers seeing from this, you know, integrated environments and for the application of those technologies?
Thank you, Sharon. Thanks for your question. And also thank you to Bentley for the invite to this infrastructure event. First, before I go into the answer of your question, maybe I would like to provide some overview on the stuff that Worley is doing around the world. So we have as a purpose, as a company, bringing sustainability around the industry and enabling our clients with achieving their net zero ambitions. Worley has done around 6,000 projects related to sustainability, and all those go from SAF to green hydrogen, blue hydrogen, offshore wind, solar. So we're doing a big spread in terms of projects. I would say that next year, we're going to be getting 75% of our revenues out of sustainability-related projects. So that's a big achievement for our company. In terms of digital, we are recognizing digital as an enabler. And the technology that I'm supporting with, which is digital twins, I'm recognizing that is helping to surface the different data that resides at the backends from clients, whether it is from IT, ET, or OT repositories. So that's helping to, let's say, provide better contextualized information at the right time, and is providing with large benefits across the asset lifecycle. So we are recognizing, for example, throughout engineering, it happens that, overall, if you consider a capital project execution, engineering can account for 10 to 15% in terms of costing. And we are seeing large impacts in terms of project schedules, project efficiencies, and on how engineers interact between each other. So personnel from instrumentation, from electrical, process, civil, they are able to have a single view on the design. Designs are less prompt to errors. Also, we have seen that in FEED and detail engineering design, projects can go much faster than they used to be. Not just that, as we move from engineering into procurement and construction, And considering that construction can take up to 40% on a capital project execution, we are seeing by means of using methodologies like advanced work packaging and as well for the simulation, and we are utilizing tools from Bentley, like for example Bentley Synchro. We are seeing that we are much more effective in how we manage the resources, whether it is personnel or whether it is materials. So if there are any, let's say, unplanned scenarios that are happening in the field, we are able to react much faster and better and be able to optimize on all the activities that are occurring. And well, I would also say that as we move from construction into operations, clients are seeing high value from implementing technology and working data-centric, meaning that they are seeing much better levels of reliability, much better levels of asset integrity, sustainability, safety, and overall, technology is changing on how enterprises are working at the current moment.
Yeah, that's great. Digital twin as enablers and data-centric, as the mechanism really to manage and streamline the optimization in terms to optimize the projects, let's say, overall. So let's move to Graham. Thank you once again, Alberto, for this first contribution here. Graham, you have spent your career leading engineering and infrastructure teams embrace digital transformation. And now, with nuclear as well, gaining momentum, I could say, I would like to ask you or get your thoughts expanding on really how digital tools are embracing and are helping really with that momentum in terms of nuclear specifically. So, and I'm asking this because we have a couple of challenges in this specific sub-industry for energy production. And one came with the complexity of working at the same time with older, large-scale nuclear plants, and at the same time enabling the development of newer technologies as the SMRs. So please.
Yeah, well, thanks for the question, Sharon. It's really good to be here. I just want to apologize for my voice first. I am recovering from laryngitis. I don't normally sound like Marge Simpson. It's a very exciting time to be in the nuclear industry. In the time that I've been involved in nuclear, it's gone from a very static, almost declining industry to one that's now like the cornerstone and the great hope for the future of the planet. In the UK, Hinkley Point C is the gigawatt scale plant that we're currently building. It was due to be delivered this year, worth saying, but they've had a few headwinds with Brexit and COVID and a number of design changes. But they're really the pathfinders for us. Across the whole industry in terms of the digital innovation. If you just put this in context, the last time that the UK commissioned a nuclear power plant was 1995. When, I don't know about you, but I was just about working out how to use email. Never mind, digital twin wasn't even a thing back then. Their aim there at Hinkley Point C is they are fully committed to digital and driving the digital agenda forward with some success and some failures along the way. And the big idea is that when Sizewell C is built, which is the next plant that's just had its final investment decision, the information architecture of Hinkley Point C is such that they're able to just copy and paste and put that, so there'll be fewer design decisions to make, a lot fewer design decisions to make around Sizewell C, even though the ground conditions are a little different. I think we're learning from the legacy, but the gap between the legacy facilities and the new facilities is such that it's really it's about learning now on Hinkley Point C. And the areas we're sort of seeing this impact is, number one is for all the engineering, is really has always taken place, or certainly, again, as long as I've been in engineering, it occurs digitally. But it's the interoperability of the data that's the issue. And as those systems have become more complex, Sizewell C, for example, has got 7,000 rooms in it, each with a distinct system or purpose to it. So the complexity is enormous. So making sure that the data are interoperable is really critical to ensuring that we were able to move the project forward as we needed to do. The second thing is around regulation. Hinkley Point C had 7,000 design changes. 7,000. Sizewell B had none because it was a complete design, but they've had to go through that process. And as the industry is moving into like the innovative space, we have a regulator that bases their decisions on empirical data. So how do you make a safety decision on something that's never been done before? So we have to start using more digital technology, more simulations to demonstrate that something is safe. The third area that we're seeing impact is in people's jobs. So I like to pick on project controls because I used to work in it. But project controls now typically spend about 2 weeks out of every month working out what happened a month ago. Absolutely pointless because you can't do anything about it. You can, you go, oh that was a bad thing that happened, wasn't it? Oh yeah, we better not do that again. What we're starting to see more is the science of prediction. So taking empirical data and using that across projects to try and work out exactly what might be happening in the future, more of a data science-led approach. And the fourth thing I wanted to bring into this room, we're not seeing so much of it yet, but this is what I want people from Bentley to really think about. I work for a company that is a service provider. You guys are a technology platform. You put those things together, what are we really providing? We're providing an experience for our customers. We're providing them with a novel way of doing their jobs, or not necessarily doing it on their behalf. And I think that's the next step for the industry, is actually looking at how we turn the digital technology we've got into sort of a pleasant experience, and reducing things like decision fatigue and being able to understand exactly what's happening in our projects at any one time. So yeah, those are the key things for me.
Thank you for your answer, Graham. That's a great way to wrap up the first round, and excellent points in terms what it is expected and how really we can help, as a service technology providers, and really improve and this sub-industry as well, that it is, gaining momentum as well, and it is in full development right now. So I'm gonna just move to the next round, the round number 2. And I'm gonna open it up the things here for the full panel, so please feel free to answer whoever wants to go first. But I just want to introduce maybe one of the main points that was discussed this morning in the keynote session with Nicholas. And we were talking about the bridge and how we are acting, filling up this gap between the natural and the built environments. So how really technology is working on that, and we as a Bentley, we are working on this. And a reflection on this, it is the work that it has been doing with Cesium and with Sequent. There are 2 excellent examples, I would say, how we are contributing, really expand the capabilities and the analysis in the engineering workflows as well. But of course, this is just my perspective. I would like to hear from you how, based on your experience, on your expertise, of course, how do you see digital twins? I think you already answered a little bit of this, but I want to be more specific in terms of the really filling up the gap between the natural environment and the built environment. How do you see in your sub-industries that digital tools are filling the gap? Who wants to go first?
Go ahead. Go ahead.
I was going to talk about something a little bit away from work, which is outside of work. I'm a keen scuba diver, and I was in the Perhentian Islands this year in Malaysia, which has just had a coral bleaching event, and which basically meant that 50% of the coral has died. And I've seen that everywhere, from Egypt down to Indonesia, everywhere along. The coral bleaching is a reality now. We're actually working with a company that on the side are doing some work to monitor a coral reef in the Red Sea. And what they're actually doing is that they're scanning about 100 square miles of coral reef to look at the environmental impact of the construction of construction in the area that may be having on the reef, and then try and do things early certainly to understand where that impact is taking place, and potentially intervene a lot earlier to be able to prevent any of the detrimental impact that there is to coral. And I think we've seen this week as well in the news, coral is at a tipping point globally. So, it's really important that we're taking these steps now to protect that complex environment. And I do think that if you can do that with something as complex as a coral reef, there's no reason why we can't be deploying AI tools to understand environmental impact above sea level, and in the areas where we're building nuclear power plants, for instance.
Excellent point.
So just moving slightly, I don't have any expertise in subsurface, so I'm not going to talk about subsurface, but just talking about how do we marry the digital world with the physical world. And this is now when we're in operations phase. So when we're designing a facility, we build a dynamic simulation model, a process model. And that process model helps us design the pipe layout. It tells us how much pressure drops is going to be, what size the pipe should be, the pump, and everyone, and so on. Now, that's a theory. And with that theory, we build a plant. And then we put that process model away. We don't look at it again. Where I see the industry going is we take that process model, we add the right sensors in the facility so that we can measure actual corrosion, actual flow rates, actual pressure drops. We put that information back into the process model, and then that process model in an operating facility can help you tweak that extra 1/3% in production. It's not going to be a large number, but it'll be a large dollar term. So what we need to do is use the digital twin we build. It's a process simulation model sitting on top of iTwin, for example, and use that in operations to better or to tweak your operations so that you can get that just teeny-meeny bit more out of your operations, and it'll pay for itself. Because I think one of the challenges we've got as an industry is that all the knowledge and all the effort we put into the design phase really doesn't get used as effectively as it can in the operations phase. So to me, to answer your question, the digital tools, we need to keep these digital tools alive for the life of the cycle, and we need to use the process simulation tools, and this is just one example. We need to use these tools with appropriate sensors built in to improve production. So what we need to demonstrate, what Bentley needs to say to the market, is my tools will help you produce more product or produce it cheaper. To answer your question, just to follow on to your question, Graham, I think one of the challenges we have is we need technology basically to look around the corner. You said that, project controls gives you a report, 2 weeks after the month is over. That's a problem you can't. It's another problem. I can't bill until I get that report either. So I have a cash flow problem. So if I can do this faster, it'll help me as a contractor get more money or get money in faster. But what we really need is to use these predictive tools to look around corners. It is always easier to keep an engine, a railway engine, on the tracks than it is to put it back on the track after it's fallen off. If a project doesn't go bad and you spend money keeping it on the track, it's a heck of a lot cheaper than trying to put it back on the track. So Bentley, give us a tool that helps us look around corners.
Well, this is quite, for me, this
That's
comment,
absolutely
okay,
for you, Sharon.
this has been recorded. I'm kidding, yes, but I think that's one of our main
That's where
role
AI
in the
comes
work.
right?
Yes,
I mean,
of
if
course.
we have enough data of why projects go bad, we should be able to use, tools, call them AI, call them what you will, to say, well, in a circumstance like this could go wrong. The what if, the risk mitigation scenarios.
Yes, I think that's the way where we are acting really as a partners in terms to really develop well-oriented technology and to be trustable, in the kind of application we can deliver. And when we said more explicitly about, how we are acting in energy production, taking all the insight from subsurface, from asset operation and engineering workflows, and putting together, it is actually representing the way that we really efficiently can do this And that's such a great point. So any other contribution on that?
Maybe I would comment on this one, Sharon. I would relate to my experience at Repsol. I was working before for the client operating company. And I remember I was working at the process engineering area. And I remember at that time having discussions with the people from reservoir production engineering. And reservoir modeling has been there for quite a long time. And also the integration of subsurface modeling with surface facilities. So surface modeling informs and help make better decisions in terms of the uncertainty that is there in the reservoir. And also, I mean, it's supporting the industry in assessing on how to place wells, how to model on those surface facilities, accounting for volumes and as well as fluid compositions. I think something that we are failing, and that was just some years ago, but I think it's still the situation. I don't see a very tight integration between different disciplines in terms of when you're talking people from subsurface, people from production engineering, maintenance, operations, process engineering. I think they all need to talk together, make sure that they don't optimize their own function without looking at the overall picture and looking at the supply chain. So I think this is primary, and well, it's one of the factors that we need to look at as an industry. And also, I would say that well, it quite often happens when we are working in projects that we look at the very short term, right? So we are trying to bring volumes sooner, try to minimize capex, try to shorten the schedule for projects. And I think as an industry, we need to look ahead into the 20 years, 30 years perspective and understand correctly on what are the impacts that we are creating in terms of sustainability, as an example. So as an industry, we need to be more mindful and as well account on all those criteria, not only short-term benefits that the owner-operators can create by means of delivering the projects faster and so on.
Yeah, I think it's quite connected, the 2 points that you are mentioning, because the first one, it is silos between disciplines, and it is, I would say, independently of the industry. This is something that it is quite reflected in every single industry, sub-industry, all across around the teams. And it falls exactly in your second point regarding how we can really optimize the long-term vision or the asset performance management itself. So it is quite one of the main focus of optimization of the assets at the end of the day. So any comment, Stephen, or we can move on? Feel free. No
Looking
pressure.
forward to the next question.
Yeah, of course. That's a great answer. So I'm going to just to make you, maybe because of the time, we are going to move to the last round, finally. So please get ready, because I'm really excited about the answers that you are going to share right now with us. And I'm going to just to give you, let's say, 30 seconds, 1 minute, so it's going to be really fast. But I want to really hear from you your boldest prediction or hope you will have with how digital innovation actually will be reshaping energy production infrastructure by 2030. So we are talking about 5 years windows. I know, and I'm going to be clear here with the rules of the round, because we are going to talk maybe potentially a lot about AI. So I want to get your more specific answers on that. And I know there are different sub-industries here. So who wants to start? 1 minute. I'm flexible.
All right, I'll take a stab at it. So we heard this morning a lot about AI. I think right now, AI will augment how we design and how we deliver facilities. And my big, let's say, big hope, I won't say prediction, my big hope is that the 98% statistic, where 98% of the projects are over budget and I think 70 are over schedule or behind schedule, is AI will allow us to deliver safely, on schedule, and on budget. And it will do it not by replacing people, but by augmenting people. It is by, it's basically a tool. So AI 250 years ago, I know I'm going over by 1 minute. 250 years ago, the steam engine revolutionized, right? James Watt's steam engine, 1700 and something, revolutionized, started the Industrial Revolution. AI may be the steam engine of the 21st century.
Wow, that's bold. Well, looking forward, the next one. Alberto, maybe?
Yes, I can take it. So if I look ahead into year 2030, I'm recognizing right now that there are many technologies that are very handy in the way we work. One is digital twins, but as well you are commenting on machine learning and AI, same as robotics. I'm hoping that, well, in a few years timeline, we get those much more integrated. And of course, if we want to deep dive into the usage of artificial intelligence, I think it's all about the data, right? So we need to take data at the center. So the big benefits for any operator are going to be they are able to handle correctly on the data sets, right? So anything that they want to survey, they will need to tune their models. They will need to do optimization of the models, and it's all going to be about the accuracy and the reliability of the data. I hope that in the future, people get released from, let's say, manual and routine tasks that are adding no value, and they can focus on what really matters and optimizing the assets in a different way.
Data integration, foundation of it all, but really integrated this time in 5 years. Good answer.
Yeah, I think by 2030, I have a couple hopes. One is that digital innovation helps us bring online a significantly meaningful, more clean energy to be powering our increasing power needs. And then number two, that digital innovation helps AI chips and data centers become more efficient because they are so power hungry. It's crucial that we make them more efficient.
We need that.
Okay, a bold prediction is that we'll have a 50-50 gender balance in construction by 2030. That'd be great. You can applaud. That's fine.
Please.
And I actually think the other side of this is that by the time we get to 2030, like no matter how wild we think we're going to be working by 2030, we won't be able to guess. But what I would like to see is, I think we'll all be more data scientists. Everyone will be a data scientist essentially. At the moment, we talk about data-driven decision making. And what we really mean is, let's just chuck as much information at people as they possibly can and hope that they can, they've got enough blood sugar to be able to work out exactly what decision to make. And I think by the time we get to 2030, decision-making should be a lot more structured and a lot easier. And I think that is actually how we're going to drive down the cost overruns and the schedules is by, making sure that people are able to make the optimal decision. I think it's probably the best way I can describe it. So yeah, I'd really love to see that. And more women.
So, Craig, will people make decisions or will machines make those decisions?
I think that it has to be people make decisions. Has to be. And I actually think one of the things that I would say, and again, perhaps is perhaps a bit optimistic, is I think that as AI technology proliferates, the value of human interaction, the value of what we're able to do as a species increases. Not, a lot of the predictions are that will decrease. Maybe I'm a bit too optimistic in that regard, but yeah, I think it should be people making decisions in construction.
They are great answers, all of them. I hope you just get inspired with those. And I'm going to open now, in the last 5 minutes of this session, the floor for your questions, your comments. Yes, please. I don't know. Sorry, just wait a minute.
I'm armed with a microphone. Okay, I'm pretty loud. Thank you. Joan Michelson, Forbes, and Electric Ladies podcast. You mentioned the regulatory environment, and it's idiosyncratic at the moment, to say the least. It's a movable object. It, one point was the anchor, and right now it's completely in flux across the globe, especially in my neck of the woods in the United States, but really everywhere. So how are you dealing with that? How are you building out? I mean, energy is so dependent upon the regulatory environment. FERC is going through its changes every week, every day, every hour. So how are you dealing with the fluctuations in the regulatory environments across the globe in all of your various projects?
Can I give you a facetious response? Hiring a lot of lawyers.
Well, that's
I mean,
true.
yeah. I mean, from a McDermott perspective, we are basically Bob the Builder of the industry, right? So the regulatory environment, we have to comply with whatever comes our way. We have to be nimble. We have to be able to move work around to different places. We have to be able to take China, for example. We have to be able to be flexible enough to build in China one day and not build in China the next day. But I think this is more of a operator challenge than it is a, contractor challenge for us at least. Our challenge is we have to keep up with it. And, and it's not just, you say your neck of the woods. Doing a project in Texas is very different from doing a project in California. Not only because of the union regulations, but also because of the reporting requirements. So what that is doing is increasing the cost of projects in everywhere, basically.
You're adding more to the legal line in your E&L.
Yeah, that's why my daughter is a solicitor and not an engineer. So, yeah.
I would say we're quite lucky in the UK for the nuclear regulator because they sort of know what they don't know. And they're working very actively with the industry to move that forward. So I don't necessarily agree that it's sort of like an immovable object in all cases. A good example is to demonstrate something is safe. A lot of what we use is probabilistic safety assessments. And if there's one thing that AI is very, very good at, it's handling uncertainty. And we're looking now at how we can use that, basically AI technology, to understand or generate those probabilistic safety assessments and perhaps consider things that a human might have overlooked when they're building their safety cases. So yeah, I think it's about engaging the regulator, speaking to them, and working with them through that.
Interesting. That answers your question.
There's one gentleman over there.
Thank you for the question.
Thanks for the compliment that I'm a gentleman. It's much appreciated. Why do we aspire to automated vehicles and automated transportation without human at the wheel, but we do not aspire to the same agenda in energy infrastructure? And I point this out because if you think about big picture, interplanetary travel eventually, we won't have humans at the wheels. We're going to have machines at those wheels. So why are we not aspiring higher in this industry?
I'm not quite sure, but a lot of the facilities we build, offshore especially, where it's expensive to get people offshore and keep them, are normally unmanned facilities. So for example, in Europe, all of the big high voltage DC substations, and these are big 2 gigawatts down in Germany, all of these are normally unmanned, and they're designed for maintenance intervals of 1 year. So the design premise is that there will be no one on that platform permanently, and you will go once a year. In the Middle East, a lot of the smaller platforms, not the big ones, are designed to be normally unmanned. All the Qatari big offshore facilities which feed gas into Ras Laffan are normally unmanned facilities. We put in emergency accommodation. But the automation today allows you not only to be unmanned, but to be remote. Ultimately, the goal is to be able to operate multiple facilities sitting in downtown Houston, for example. And the industry is moving that way. But it also goes back to regulation, is that there are regulations which require you to have people there. It's like the trains in London. You don't need guards. I mean, I'm going to get into trouble for saying this. You don't need guards on trains in London, right? But the unions require that you put them in. And this is a gentleman who stands outside and waves the flag. The union requires it. So it's not really technology, it's us. I mean, let me ask you a question. I don't know how you got to Amsterdam. Would you be comfortable flying on a plane which had no pilot? Maybe yourself you would be. A lot of people probably would say no.
I was on a train that had no driver.
Well, the DLR in London has no drivers.
Yeah, so we're almost there. We're
yeah.
there.
But
I would just say that as I'm not an engineer and I'm not an insider in the industry and I'm not in the construction world, I do work in oil and gas, but I would just make the observation that the power of these tools to consume and do things that humans can currently do but struggle is outstripping our vision for how far we should be taking these tools. And I like your point that the offshore platforms, et cetera, are becoming as unmanned as possible. We have underground mines that are very close to being thoroughly unmanned. So there aren't going to be the people to do much of the work that I think sometimes we're building into our infrastructure for the future. We need to be thinking, how do we get people out of the infrastructure as much as possible?
Agreed. That we'll all go scuba diving with Graham, right?
Absolutely. Please do.
That makes sense.
Please do. I just to add to that, I actually think the difference is the risk profile. I think use the example of a driverless car. Notwithstanding the impact that a road traffic accident does have on people's lives, if a driverless car fails, the impact compared to if a nuclear facility fails is, there are degrees of separation. So I think we're, I'm not saying it won't happen, I just think we're way off having the confidence in the technology to put not just our lives in our hands, but our entire country's lives in the hands of that sort of technology at the moment.
That's great. Any other question here?
I think, Sharon, if I can add to that question, because I have a very interesting point. I think I would break that question into two areas, and I think it's very different whether you are talking about a brownfield or a new greenfield. If we are talking about a new greenfield, there is sufficient technology to enable full autonomy. And we are seeing that in some assets. And for example, there are high incentives when you're talking about offshore oil and gas. But the problem comes when you're talking about brownfields, right? Because they have already an already established infrastructure and architecture. And of course, I have seen that clients, they need to take a pragmatic view in terms of investment, right? So they cannot go from, let's say, current levels of autonomy to full autonomy in one step. And as well, they need to think on how they are going to pay for that, how they are going to make sense of the investment that they need to undertake to go to full autonomy. So I think it's more of an investment decision, and that criterion between brownfields and greenfields, I think, is primary.
Great, let's comment on that. Any other question for? No? We have one from the online audience, so let me read it here for all the audience. So, what more can be done to encourage the next generation of engineers with digital technologies to advance the energy transition?
I'll take that. I think it's actually a great question. Getting the next generation of engineers to get hands-on with digital technologies is not a problem. They've all watched Iron Man. They all think engineers are Iron Man. The trick, it's not a trick, but to encourage, they want to use digital technology, but a lot of them end up going into things like game design or financial services or whatnot. But the difference for us is the sense of mission. That's what's making the difference. So, as I said, nuclear power is now seen as a key component of the energy transition. It's great. Low carbon. We're going to reduce the impact of climate change. But there's also some other initiatives coming through as well. There's an organisation that we're working with in the northeast of England. They're called Community Nuclear Power, and their plan is to buy 3 small modular reactors and build them in quite a deprived part of the country in Middlesbrough, and use that as a way of I suppose accelerating the development of the area, bringing jobs into the area on top of the other stuff that they're doing, reducing carbon, and they're actually talking about using it to create aviation fuel as well, to sort of decarbonize aviation. And I think that's what really attracts the next generation to, when we ask our graduate intake why they've chosen to come and work for A-System, 9 times out of 10, they say they want to contribute to the energy transition. So it's that sense of purpose.
Yeah, I agree. I think my problem is the opposite. It's everyone wants to work on energy transition, right? I mean, if you give someone a traditional oil and gas job, you know, there's, especially here in the Netherlands or in Northern Europe, everyone wants to work on energy transition. I think the challenge is once they join, is to keep them. Retention is an issue because the technology they use in their daily life is much more advanced than the technology we use to deliver projects. So because these are digital natives, these are people who have not learned technology like myself, for example, but they were born with it. And they see that their daily lives are much more digital than their work lives. And that is a retention problem for us.
That's right. Yes. Pretty good. Well, I'm going to take another one from the online. I think it's going to be the last one because of the sense of time here. But I think this is straightforward to Steven. For subsurface investigation, can you share how 3D modeling enabled more accurate expectation of well performance as compared to all section cuts methods? It's quite specific. It is allowing reduced conservative assumptions, allowing less test drilling by X%. I think we can maybe overview.
I'll take it.
It's not option.
Yeah, I mean, having highly accurate 3D models, you know, absolutely makes what we're doing possible in geothermal at Fervo right now. And compared to old section cut methods, having a 3D view of temperature in the subsurface, for example, you know, we're drilling wells to 8,000 feet. Wells are one of the most, and drilling is one of the most expensive components of our project. And drilling success can make or break these types of projects. So having a highly accurate model of that temperature at depth from the start allows us to plan out handfuls of wells at a time rather than a more iterative approach of drilling a well, updating, drilling a well, updating. It allows us to do things like drilling in batch. So we'll drill 8 horizontal wells from a single pad and put our drilling rig on a track. And drill vertical section, sliding the rig back and forth, then drilling the lateral section, sliding the rig back and forth, and with full confidence that we're hitting the temperatures that we know because we've modeled in 3D and we've validated those models with prior more cheap exploration wells. So you know, it has a huge impact on costs, has a huge impact on time, and it allows us to be more aggressive and less conservative in our plans.
Yes, as we are discussed so far. So we are just running out of time so far, but I just want to take a moment really before to leave the room to thank you again to the distinguished panelists that we work with us today, and really appreciate, you know, behalf of Bentley to be here joining the event as well. So Graham from Assystem, Steven, good luck as well with the finalist process. From Fervo Energy, Alberto from Harley Consulting, and Basin from McDermott.
So Sharon, I have a question for Sharon.
Oh, no, it is not allowed. Sorry.
What is your bold prediction or hope for 2030?
Oh, that's bold. Okay. Maybe I'm not an optimist, I could say, because I really go with Alberto on this one. I really think we have a lot of still issues with data management and silos in disciplines that we really need to face it correctly, and we really need to work on the base on this. This is not EI on top. This is EI really using as a enabler across all the data layers. So I'm with you on this one, and it is maybe not so bold, but it is my honest answer to you, Basin. So really, thank you for joining us as well online. We really appreciate and join the conference. Looking forward to connecting with all of you later today. And please join us for the reception cocktail and later for the networking event tonight at 7 p.m. So thank you, all of you.